So extreme values of a function happen at either critical points or at the left and right endpoints of a given interval, like we're given here. A critical point just means you take a derivative, you set it equal to 0, and wherever the derivative equals 0 or wherever the derivative fails to exist, those are critical points. Okay, so like this term right here, that's x to the negative first, right? So the derivative, the negative 1 comes down, and then the power gets reduced by 1. Or in other words, that's negative 1 over x squared. That's the derivative of this term. And the derivative of natural log of x, that's 1 over x. Okay, we're supposed to set that derivative equal to 0. Now if you try to solve that equation for x, what problem are we going to face here? Right? We want to get x out of the denominator, so we want to multiply everything by x squared, because that way the x squareds will cross cancel and we'll lose one of the x's over here like we want. Okay. Actually, here, before we do that, this is our derivative, right? This is our derivative. Remember the two places where the derivative equals 0, which is what I was starting to go after. But before that, it probably makes more sense to say where the derivative fails to exist. At x equals 0, we have we have a divide by 0 problem, right? So the derivative fails to exist at x equals 0. That's a critical point. That's one we want to investigate. Okay, let's go back to solving this equation. We want to multiply both sides by x squared. So x squared times 0 is 0. X squared times negative 1 over x squared is negative 1. And x squared times 1 over x, that's 1x. So if you finish solving that equation, you should get x equals 1. So those are the two critical points. Okay, then we also have these endpoints. So what you want to do with critical points is they're not guaranteed to be maximums or minimums. You got to test them. And you kind of have to test them anyway to see whether they really are the biggest or the smallest point in some area. So let's make a quick number line, and all the numbers of interest we'll put on there. Oh, actually, look, the interval says between 0.5 and 4, so forget about this one. That's to the left of this number, right? So we want to analyze, here's x equals 0, that's not part of our interval. We want to analyze 0.5. We want to analyze 1 because that's a critical point, and we want to analyze 4. So let's see what the y values are. At x equals 0.5, we're going to plug that into the original function and see what the y values are. Okay, so 1 divided by 0.5 is 2, and then 2 plus natural log of 0.5, I don't know what that is off the top of my head. So there's natural log of 0.5, and then 1 divided by 0.5 is 2, we said, so we want to add 2 to that. So if you plug in 0.5 in for x, you get 1.3 roughly for y. If we plug in 1 in for x, 1 over 1 is 1. Natural log of 1 is 0, so 1 plus 0 makes 1. And if we plug in x equals 4, 1 over 4 plus natural log 4. Let's figure out what natural log 4 is first, and then add 1/4 to it. So 1.64. Okay. We were asked for extreme values. The endpoints of the interval and critical points are the only places where you could have extreme values. Okay. So at y equals 1, at x equals 1, the y value has reached a minimum. You don't even have to check these points because these aren't critical points in between here, right? Y equals 1 is our minimum value. It reaches a minimum at 1, 1, 1 on the x and 1 on the y. Because that's y equals 1 is lower than all the other potential places where we could have mins or maxes. Look, it's 1.3 here, it's 1 here. It has to be decreasing to go from here to here because there's no other critical points in between there. Y equals 1 is here, y equals 1.64 is here, so it has to be increasing between here. Okay. And then our maximum, the extreme value here, 4 in the x, 1.64 in the y, because that's the highest of all those potential maxes or mins. Okay. Just taking a look at the book. The book doesn't use the decimal values, even though they give us 0.5. I don't understand that. Yeah. Yeah, but this is what they have if you convert their answers to decimals. This is the minimum, and then this is the maximum.